Okay, this is video 4 of 1-5, and we're just doing this one last problem here. It shouldn't take too long. So go ahead and watch this problem.
Okay, this next one's going to be a little bit more difficult.
Actually, it will
Determine
take
the
a
minimum
while.
stopping distance for a car traveling 14.0 meters per second, for which the driver has a reaction time of 0.50 seconds, and for which the deceleration is 6.0 meters per second squared. Okay, now here's the deal. In looking at this, I have two motions. Okay, there's two parts to this. There's the part when the car is going to travel at a constant velocity of 14 meters per second for 0.5 seconds because he hasn't hit the brakes yet. He notices that he needs to hit the brakes, but it takes him a half a second to actually hit the brakes. So he's going to go for a certain distance before he starts slowing down, and then he's going to start slowing down. Now we can look at this in a couple of different ways. We could either say that we could figure out how far he went in the first motion using 0 as our initial starting point, and then saying that the initial starting point is the end of the first motion for the second motion, right? I can go with that certain distance and then use that distance for my initial position for the second part of the problem. Or I could just use 0 for both initial positions and then add the two motions together. Either way, I'm going to end up adding two distances together. The distance that the car traveled at 14 meters per second during the reaction time, and the distance they traveled during the deceleration time. So I'm going to end up adding two different things. And I generally, and you can do this either way, I generally like to do this where I say that the total distance, and I'm going to just write this out first. This is only something I only do when I have a two-part problem. I say the total distance is going to be the first distance plus the second distance, and then I find out how much each distance is going to be. Now, individually finding out how much each of these distances is going to be is not going to be that difficult. It's just how do I put all of this together that causes a lot of people problems, and this is the way to put it all together. I'm going to say that I have a total distance, and that means I need to add the first distance plus the second distance. So let's work on this first distance first. I may not know how to solve the problem, but I do know how to start the problem for this first motion. So I'm going to try and find x1 first. Okay? Okay, so I'm going to say what's my initial position for this? x0 equals 0 meters. And then I'm going to say x1 instead of x, just because that's kind of how I set up that problem. I don't know how far x is, but I know that I need to find it. Okay, now in this case, for this 0.5 seconds, I'm traveling 14.0 meters per second, okay? And I'm traveling 14.0 meters per second the entire 0.5 seconds. So I have an average velocity or constant velocity here that I only have one arrow for. I'm not accelerating at all. I just have a v, and that v equals 14.0 meters per second. Okay? And I don't have an acceleration during that time, or a deceleration. I don't have any kind of an acceleration, so I don't need to worry about that. And I've been told how much time I have. So I'm going to solve this part of the problem by saying given x0 equals 0 meters. I don't know what x1 is, but that's what I need. I need x1, that final position after the first motion. Okay, and then I also have a v of 14.0 meters per second, and I have a time of 0.50 seconds. Okay, and so to find a formula, I start asking my questions. My first question is, do I have time or do I need time? And I do have time. I don't need to find time, but I have time. So I can't use that last formula. I cannot use v squared equals v0 squared plus 2a times x minus x0. My second question is, do I have an acceleration or do I have a constant velocity? My answer to that is I have a constant velocity of 14.0 meters per second. Therefore, I have to use x equals x0 plus vt to find that distance. And we're going to say that that distance is x1. All we have to do is plug the values in and solve. I don't have any value for x0. Okay, it's 0. I just need to plug in vt. So x equals 14.0 meters per second times 7.0 seconds. And my seconds cancel out there, and I end up with meters. So I don't know why I said 7.0 seconds. Let me erase that. That's 0.50 seconds. I guess what I was thinking was the answer. So 1/2 times 7 is just going to equal, or 14 is going to equal 7.0 meters per second. Okay, so that's my x1. Okay, so I can come back up here and put that value in. I can say it's going to be 7, and it's not meters per second either. I just finished saying that it wasn't meters per second. It's meters. Okay, 7.0 meters. So I can come up here and say, for my x1, I've got 7.0 meters. Now I have to find out how far I went during my second motion. And yes, I know it's annoying to have to create a second problem for this, but that's the nature of these things. 0 in positive x direction. So now my initial position again is going to be 0 because I'm just talking about this second motion here. And now I'm going to say that my second x is, I don't know. But this time, instead of going at a constant velocity of 14 meters per second, I'm now going to be starting at 14 meters per second. V0 equals 14.0 meters per second. And I'm going to be slowing down to 0 meters per second. My final velocity is going to equal 0 meters per second. Okay? I also have been told that I have an acceleration or a deceleration here. So I'm decelerating, and if my car is moving in the positive direction, the direction of the acceleration that would slow it down has to be in the negative direction. So I have a negative acceleration here because the acceleration is pointing in the negative direction, and that's what's required, right, to make it slow down if it's going in the positive direction. And so I have to say it's not 6 meters per second squared. I have to say that it's negative 6.0 meters per second squared. Okay, so now I've got all of those values. I don't know how much time this is going to take, but I can write all my given values down. Given x0 equals 0 meters, x equals question mark, I don't know, I don't need that. The v0 equals 14.0 meters per second, or I do need that actually, so let me put that. I need x2, that's my final position here. V equals 0 meters per second. My acceleration equals negative 6.0 meters per second squared, and I haven't been given a time. Okay, and just by me saying that, already you should be somewhat conditioned to knowing that I have to use that last formula. To find this x, I have to use my last formula, and v squared equals v0 squared plus 2a times x minus x0. Okay, so there's nothing in this that I've had to really do to think about. I just follow this pattern here, and now I'm going to make sure that I cross out everything that's going to drop out of this formula. I know that my final velocity is 0, so 0 squared will be 0. That drops out. I know that my initial position is 0. That drops out. And I'm going to circle x because x is what I want to find. In order to get x by itself, the first thing I'm going to have to do is put v0 squared on the other side of the equation. So I'm going to say negative v0 squared. And then I have 2ax left on the right side, so I'm going to divide both sides of the equation by 2a, and that's going to leave me with x. Okay, and so now I have my formula that I can just plug values into. So I'm going to solve. I'm going to say x equals negative, and my initial velocity is 14.0 meters per second. And I'm going to square that, divided by 2 times the acceleration, which is negative 6.0 meters per second squared. And now notice the two negatives here make it so that this number is going to be positive, and that's what I need, right? It's going to be positive. And let's look at something else here. In the top, I've got meters per second, and I'm squaring that. And if I square meters per second, that gives me meters squared per second squared. And then I'm dividing that by meters per second squared. And those are going to cancel out. And this meters is going to cancel out with one of these meters. That's going to leave me with meters. So that's what I need, right? So make sure your units cancel out correctly as well. Okay, and that's going to give me 16.3 meters. So now I go back up here to my top of this and add this in. 16.3 meters. And that gives me a total of 23.3 meters. Okay, so if I also do the conversions to something that you understand a little better, if I multiply 23.3 meters is going to be about 25 yards or 26 yards. So it's going to take me about 75 feet to stop. And if I look at how fast they're going, I know that they're going 14.0 meters per second. And I know that we've got this trick that we can turn meters per second into kilometers per hour if we multiply by 3.6. And if I do that, then I end up with 50.4 kilometers per hour. And then if I multiply that times 0.62, which is a conversion factor to miles per hour, I get that we were initially going 31 miles per hour. So if I was going 31 miles per hour, it would take me about 75 feet to stop, about 25 yards. So about the fourth of a distance of a football field. So that's quite a long ways for even such a small speed. So remember that when you're driving. It takes a long time to stop. Okay? So that would be how we would answer this problem. Okay, so go back to the presentation and we'll finish the presentation.
Okay, so that's it for this discussion. We've finished our problem solving discussion, and just make sure you turn your worksheet in and we'll be good.